So good morning to all. So in this video lecture, I am going to discuss about the topic three-phase induction motor. In today's scenario, all major industries are used to this three-phase induction motor. So maximum 95% and above industries are using this three-phase induction motor because of less maintenance and lifespan is high. The first thing we are going to discuss about the construction details of three-phase induction motor. So majorly it has two parts. One is stator, another one is rotor. So stator is nothing but stationary armature part. Rotor is nothing but a bar type of rotor. So in induction machine, normally it has two types of rotor. One is squirrel cage rotor, another one is slip ring rotor. So apart from this, machine having a central shaft will be there. Then after that shaft we are having the rotor part. So rotor part for squirrel cage machine, it has the two endings which are connected in both ends of the rotor shaft, and also rotor having the bearings. The rotor have own slots and the rotor winding also it has. Then if you goes to the stator terminal, the stator having stationary armature. So the armature having three-phase nature. So R phase, Y phase and B phase. So all the three phases are displaced by 120-degree phase difference. And also the stator having a core and slots. Normally it is semi enclosed slots preferred for this type of machine because of the flux passing area would be very high. Secondary thing, maintenance is easy if suppose any windings are damaged. Then also if go to the very big machine, there is a need of cooling fan which deliver the heat from inner side to outer side. So already said that the major part, stationary part, rotating part, stator and rotor. So this is your cross sectional view of induction machine. So this will be your shaft. Then from the shaft we are having the stator having this type of having a stator core and stator slots. The stator core is made up of silicon steel. So number of stampings are together to make a stator core. Then the small portion which means that slot. So in the slot portion we are going to fix our stationary armature winding. So then some parts we have to identify. First one is stator frame or yoke. So yoke is nothing but the outer core of the machine, first thing. Then the main function of the yoke is to hold the stator poles. So this is the major function, and also any dust particles from outside the machine, it does not disturb the inner part of your machine. So that is the external protection is given by the machine only from the yoke. Then stator core. So normally the main function of stator core to carry the alternating flux. So in order to reduce the eddy current loss, so we are going to laminate each core part of your machine. So the core is made up of silicon steel lamination. So this insulated from each other by varnish. The slots are cut on inner periphery of the core stampings. The stator windings are placed in these slots. Then stator winding. So stator winding is here normally a copper winding we are going to using here. The stator winding is made up of super enameled copper wire. So three-phase windings are placed in the stator core and slots, and the 6 terminals are brought out. So each phases we are having 2 terminals. So totally we are having 6 terminals. So they may be a star connected or maybe a delta connected, depends upon the application. And the windings are connected in normally star rating, connected in star at starting period of time. The rotor is nothing but a rotating part of your machine. So the rotor is mounted on the shaft of your machine. It consists of a hollow laminated core having the slot on its outer periphery. The windings placed in the slots may be one of the following 2 types. One is squirrel cage rotor, another one is slip ring rotor or wound rotor or phase wound rotor. So the school cage rotor is most probably used in all industries. Less maintenance. The thing is, the rotor consists of cylindrical laminated core with the parallel slots for carrying the rotor conductors. So the school cage rotor consists of aluminum or brass or copper bars. So they are utilizing bars. The aluminum or brass or copper bars are called rotor conductors. Um, so and are placed in the slots on the periphery of the rotor. So in a stator we are using copper winding for the stator winding. Here we are using the rotor winding is nothing but rotor conductor. That rotor conductor is nothing but the is made up of aluminum conductor or brass conductor or copper bars. So we are going to fix in the periphery of your rotor. The rotor conductors are permanently shorted by copper or aluminum rings. It is called end rings. So to provide mechanical strength, these rotor conductors are braced to the end rings and hence for complete closed circuit resembling like a cage, and hence got it is named as school cage rotor. This is your model of school cage rotor. In both ends we are having the end rings. Between the end rings we are having some bars. So that bars is nothing but rotor conductor. In between the rotor conductor we are going to place your in between the rotor conductor we are having the rotor core part. So rotor bars, in between we are having rotor core. Then another type of rotor is nothing but slip ring rotor or wound rotor or face wound rotor. So this type of rotor is same as your stator nature. So stator having 3-phase winding and similar stator core. So the same setup will be arranged in the rotor portion also. It is also having a 3-phase winding. So that winding is also displaced by 120-degree phase difference. So the insulated conductors are put in the slots and connected in the form of 3-phase double layer distributed winding with a similar to your stator winding. The rotor windings are connected in star connection. So this is your model. So we are having the shaft, then shaft we are having R phase, Y phase and B phase, 3 winding setup will be there. Then externally we are having some 3 slip rings will be there. So that slip rings connected into the 3 external star connector resistance Eurostat we are having. Okay. So open end, the open end of the start circuit brought outside the rotor and connected to the insulated slip rings. The slip rings are mounted on the shaft with the brushes testing on them. The brushes are connected to the 3-phase variable resistor connected in star. The purpose of slip rings and brushes is to provide a means for connecting the external resistor in the circuit. Then the principal operations of 3-phase induction machine. So normally in a stator we are having 3-phase winding. So we are going to giving the 3-phase AC supply to your stator coil. So the corresponding stator coil produces the stator flux. So that particular flux is nothing but the rotating magnetic flux, because we are having 3 windings, we are giving 3-phase supply. So 3 windings and 3-phase supply both will create the rotating magnetic flux in the stator side. So from the stator side to rotor side, the rotating magnetic flux is passing through it. So now we are having the rotor. The rotor is nothing but the bar conductor. So whenever the magnetic flux is linking a conductor, an EMF is induced. So in our magnetic flux is rotating flux, the conductor is stable conductor. So then it is applicable to produce induced EMF. So from now the rotor is produced induced EMF. And now we connected both the end of the rotor using end rings. So that end rings, because of that end rings, induced EMF in the rotor will be created a short circuit current. So that current is passing into the rotor conductor hall. So now the rotor having the current, so that current is capable to produce another magnetic flux. That magnetic flux is passing against our rotating magnetic flux. So now we are having stator flux, now we are having the rotor flux. So both the fluxes are interacting each other and it has some small torque. So based on this torque the machine starts rotating. So this is the working principles of your induction machine. So this will be okay. Now the applications of 3-phase induction machine. So normally the machine is having a moderate starting torque. So the small weight lifting carrying capacity it has have. So it will be used for lift, crane, hoist, then large exhaust fan, lathe machine, crushers, oil extracting mills, textile mills. So wherever there is an industry, definitely the three-phase induction motor is uh, uh, is having a major role. So thank you for your listening.